All right, so the first thing I wanted to say, which I said in class before, is that all of these functions in question 1 were looking at the chain rule. So today we're going to be going through the chain, product and quotient rule. And for you people that have done year 11 methods only, this is going to be a bit of a brain fade. It's going to be tough work. So you'd have to watch this video a few times, as I said. Now, first of all, I would like you to think about what a chain is. Okay, we've got all of these links. I want you to think about a function inside a function. Function inside a function. Because all of these functions here, we've got a function which is 1 minus x squared, and that function is then being to the power of a half. We've got sine of x, which could be the product rule. That could be equal to sine of x times sine of x, and you can apply the product rule if you like. However, I think the easiest way is application of the chain rule. We've got a function 1 minus 2x inside of inverse tan, and we've got sine of cos inverse cos of x. Now, as I said, you have to memorise all of the things on your formula sheet, but they're not very helpful because, for example, if I've got the inverse tan, the derivative of inverse tan of x, that is not very helpful because all it says to us is it says that it's 1 plus x squared. Now, as it turns out, if we're using the chain rule, we could be letting the function, which is more complicated than x, we can be letting that equal u. And as it turns out, this is u squared. So if u was 2x over 3, then suddenly this function, or the derivative of this function, becomes much harder. Now, I'm going to show you the long way of doing it. This is the methodical way so you make less mistakes. Eventually, things such as this, you're doing in one step, but I don't expect all of you to be able to do it one step now. What we're going to do is I'm going to show you how the chain word works. Now, first of all, the chain rule is that dy dx is equal to dy du times du dx. Okay? These are not fractions that just cancel out. We have to apply limits and things like that to prove that. I'm not going to go into that today, but this is not a fraction where they just, numerator cancels out with the denominator. It doesn't work that way. Okay? But this is the chain rule, and you need to be able to memorize this. So let's show you the long way to do it for now, and then we'll go from there. So now the function which is inside another function, we always let equal u. So we're going to let u equal 1 minus x squared. And then you set it out like this, where du dx, or u dash if you like, but we'll keep it in this mode here. Oops. Du dx is equal to minus 2x. Therefore, y, though, is not equal to 1 minus x squared to the power of a half. It is u to the power of a half. And therefore, deriving that is a basic polynomial. Dy du is equal to a half u, and what do we do to the power? We drop it by 1. So a half u to the power of negative a half, or if you like, that is equal to 1 over 2 root u. Are we okay with that? Okay, 1 over 2 root u. Now, I'm just going to pause the video now because I want to clean up. Resume. Okay, so what we now need to do is applying the chain rule, dy dx is therefore equal to dy du times du dx, which just conveniently happens to be this times this. But remember what u is. We've made u equal something, and we've used the chain rule to make our life easier. So that is 1 over 2 root u times minus 2x. But that's not technically right because we should be replacing u with something else. And that u is 1 minus x squared. So therefore we've got, let's do it. It's minus 2x over 2 square root of 1 minus x squared. And that's your answer. Well, I guess we can simplify those 2's, can't we? Minus x over the square root of 1 minus x squared. And that's your answer. That's what your CAS calculator would do. Now, how do we do this? How do we do it in your calculator? Go to your elements key. And then you go, look, let's have a look at this. We've got d by something. Okay, use that one. And d by dx of the square root of 1 minus x squared. Oops. Sorry. I'm very sorry. 1 minus x squared. And look at that. If we go over across here and we press enter, look at that, minus x square root of 1 minus x squared. Isn't that brilliant? I can derive a basic thingy. Okay, now as I said, you could use a product rule here, but I'm going to apply the chain rule again. What is in the function which is inside another function, or the function which was having something happen to that function, is u is equal to sine of x. du dx from year 11 methods, oh actually you didn't learn that in year 11 methods, did you? Is cos of x. You need to know this from your formula sheet. Y is equal to u squared, dy du is equal to 2u, so therefore dy dx with application of the chain rule. If you set it up like this, ladies and gentlemen, u and y, du dx, dy du, then it's just this thing times this thing, which is 2u, but we're going to replace u, 2 sine of x, cos of x, which is conveniently sine to x. Let's see what happens in the calculator. If I do that, will the calculator be smart enough to do that and change it? I'm not sure. Sine squared of x. So we go to the elements key, and we go to this, and we go d by dx of trig sine of x, and then you've got to go outside the thing and go squared. If you do that, oh, look at that. Doesn't do it, does it? Doesn't apply, because if the calculator's not smart enough, it's going to just have it like that. We could have used the product rule, and we'll get to that later. If you know the product rule, you're more than welcome to try it, and you'll get the same thing. Okay, what about this one? Now, this is what I was saying to you. The inverse, the derivative, let's do d by dx. This is where it's not that helpful, of inverse tan of x inverse tan of x in your on your formula sheet, as we discussed, was 1 over 1 plus x squared. But remember that if I've got something a little bit confusing, that it's this we would let equal u, this would be then u squared. So it's not always going to be an x squared, is it? That's why the formula sheet's not all that helpful. So what we do is we let u is equal to 1 minus 2x, and we let y is equal to inverse tan of u. And the reason why we do this is because you can then copy the formula sheet, and then you can replace u in at the end. So therefore du dx is equal to minus 2, and dy du is equal to 1 over 1 plus u squared, and therefore dy dx, using the chain rule again, is equal to minus 2 on 1 plus u squared, which is 1 plus 1 minus 2x all squared. Would I leave the answer like that? No, I wouldn't. I'd probably expand the brackets out. So that's going to be minus 2 over 1 plus 4x squared, because your calculator is going to simplify that. And then you've got plus 1, and then you've got minus 4x. So your calculator is then going to say that that's minus 2 over 2 plus 4x squared minus 4x, and it might even go take 2 out as a common factor, I think it'll do. Okay, so you've got to be careful. You can get an answer which looks completely different because your calculator's done this simplifying. Take 2 out as a common factor. We've got 1 plus 2x squared minus 2x, and then we cancel out these 2's. So the answer will look something completely different to what you've done, unless you have gone ahead and simplified. All right, let's have a look. The derivative of inverse tan of 1 minus 2x in the CAS. So we do the same thing. X, and remember that we've got trig, and it's the inverse tan of 1 minus 2x. There you go. Isn't that what we had? Very good. Can you see there that even though eventually you will get really good at applying the chain rule and doing it in one step, do you need to do this to get full marks in an exam? No. However, students always get these, you know, what's the antiderivative of r cos in your exams? They can say r cos. Isn't that right, Sherry? R cos. Sherry didn't know what r cos was in her SAC, which really cost her some marks. Okay, you've got to get used to how the examiners might ask. R cos is what? Inverse cos. R sine, inverse sine, and so on. Okay. Sorry to single you out there, Sherry, but now this last one. If you didn't use chain rule, then remember, but this is not a product rule because we've got a function inverse cos of x inside another function. So, same thing. This time though, what we're going to do is we're going to let u is equal to inverse cos of x, and straight from your formula sheet, you can know what the derivative of inverse cos of x is. So, let u is equal to inverse cos of x. And then y is equal to sine of u. Du dx is equal to, from our formula sheet, what is it? Negative 1 over the square root of 1 minus x squared. Is that correct? Good. And dy du is equal to cos of u. Cos of u for the time being. So therefore, dy dx, applying this and multiplying these two out here, is equal to negative cos of whatever u is, which is inverse cos of x. Okay, it's getting a little bit tricky now, isn't it? Over what? Square root of 1 minus x squared. Do you think that we'll just leave it like that? No. What does the numerator become? Negative x. Good job. Over the square root of 1 minus x squared. Let's have a look. Inverse, a sine of inverse cos of x. So, if I go to this thingy and you guys, of course, if you had this in an exam too, would you do it by hand unless you had to show method marks? No, you wouldn't. All right? Don't be crazy. Don't be crazy. You be crazy. Sine of inverse cos of x. And what does it say? Minus x on square root of 1 minus x squared. Isn't that what we had? Yes. Okay, very good. Now, we've now done chain rule. I'm going to stop the video there because we're going to have a chain rule video, product rule video, and a quotient rule video. It's only 13 minutes. You people have done Year 11 methods only. You'll be watching this 3 times, which is 40 minutes of private study. Stop.